Now let's talk about significant figures. So when we are presented a number, we need to understand how accurate this number is compared to the real quantity. Now, we will count how many numbers we have from left to right, how many non-zero numbers we have from left to right. That will tell us how many significant figures a number has. For example, this 0.03, it has one significant figures. 0.0075. So this 700 doesn't matter. And we start from 5, 1, 2. We have two significant figures. So from the first non-zero number, count how many numbers we have. If we have 1500 gram, how many significant figures we have in this number? This one actually has only two. We'll come back to that later. Now, the best way to understand significant figures is scientific notation. In this 1.500 times 10 to the 3 gram, if we write it as this, we have a point here, then 1.500 has 4 significant figures. 1, 2, 3, 4. 1.50 has 3 significant figures. 1, 2, 3. 1.5 times 10 to the 2 gram has only 2 significant figures. So what's the difference? This one tells us we measured up to this. We measured up to 1 gram. And we're pretty sure this object has a mass that is 1,500. So the uncertainty with this measurement is in maybe 0.1 gram. Now, if we write it as this, then which means we measured up to 10 gram. So the uncertainty of this measurement would be somewhere around 1 gram. So this is a much more precise measurement. And if we look at this one, it'll be roughly 150 gram, right? But this one we only measured up to 50 gram. So the uncertainty is a gram. The uncertainty is a gram in this notation. See, if we write it as this, 300 without the point, then it only has 1 significant figures. Only these 3 count as significant figures. So if you write this as previous slide, this one, it only has 2 significant figures. So the uncertainty in this number communication is that I measured up to hundreds. So it could be the actual quantity could be somewhere 1,060 or 1,500 or 1,600 or 1,400. That's what it means. It means I have no idea what those two numbers should be. I only care about the hundreds. So it's not a very precise measurement. Now, on the other hand, this one, 3.00 tells people I measured up to this. I'm very, very confident because I measured up to this digit. I know this quantity has almost 0 in this at this digit. That's what significant figures means. It tells people how precise your measurement is and how precise this number, how much information this number tells me about this object. And we can do algebra with significant figures, right? So what's the rule if we add 2 quantity? For example, we add 123 and then the other number we got it very, very precise, 5.35. If you put it into calculator, it would be 128.35. But it would be wrong if we write it as 128.35, because if you think about that, I only know this quantity is roughly 123. It could be 124. It could be 122. And then the other quantity, even though I know it's 5.35, if you add this 5 to this 3 has huge uncertainties. So the only thing I can know, it'll be roughly around 8. So anything after anything here, the information will get lost after you add it, right? Because I don't know what is the number after this point for this one. So after the sum, I can only take 3 significant figures after I sum those two numbers together. Now, on the other hand, this one, I know what this number precisely here. I know this number precisely here. So I can keep what's happening after the subtraction.